Section 3.3, Polynomial Division. This is the last section for the week. Remember that 3.2 is due tomorrow night. Not very many of you have started that. And 3.3 is due by Thursday night. Coming on Friday is a quiz of some sort on Canvas, maybe WebAssign. I haven't really made up my mind yet. But do watch out for the quiz coming your way on Friday. So we're going to do two division types. We're going to do both long division and synthetic division. And so the first type of division we're going to do is long division. So I kind of like to give you a diagram of how to set up long division. Okay, so typically what we do is we have a division symbol, right? And under the division symbol, we put our polynomial, p of x. Okay? We're dividing by the divisor, d of x. So if we wanted to do, like this example down here, 6x squared minus 26x plus 12, this would be the polynomial that goes underneath the division symbol, and our divisor is x minus 4 because that's what we're dividing by. Now when we divide, we're going to get a quotient. That's the answer that's up here above the division symbol. And then if we have a remainder, we call that r of x. All right? So there's two different ways to write our answer. That's what this box here is explaining, the division algorithm. And the homework is going to ask you to write the answer in both ways. So we can do p of x divided by d of x, and that's going to equal q of x plus the remainder r of x over the divisor. So if we had like a remainder of 7, we would write that over what we were dividing by. This is a typical way of writing a division solution. We can also write a different algorithm. Okay, p of x equals q of x times d of x plus r of x. I actually kind of prefer this way because it's easy to check. We would just multiply these two together, add the remainder to it, and we should get back to the original polynomial. Right? So remember, we are going to have to write the answer both different ways, and I will try and model both at the end of each one of these problems. So let's go ahead and work our first long division. Actually, you know what? Let's work this little numeric one up here, because I know it's been a little while since you've done division. So we're doing 38. We'll put that under the division symbol. We're going to divide by 7, right? So the first thing we do is we ask ourselves, how many times will 7 go into 38? Right? So 7 times 5 is 35. It wouldn't go any more than 5 times. So I'm going to put the 5, and remember, the 5 doesn't go into the 3. The 5 is going into the 38. So we're going to put the 5 above the 8. So the next step in long division is we need to multiply these. Right? So 7 times 5 is 35. The next step is we're going to subtract 38 minus 35, which is 3. Okay. 3 is less than 7, so we can't divide anymore. So this is our remainder. So I'm going to put 3 over 7. Okay, 5 and 3/7. So we're going to do the same kind of pattern when we do the long division with polynomials. So let's go ahead and set this one up. Okay, so we're dividing 6x squared minus 26x plus 12. So the 6x squared minus 26x plus 12 is written underneath the division symbol, and then we're dividing by x minus 4. Now this is really important. If the polynomial you're dividing has a missing place, okay, so if it skipped over the x term, if it was missing a term, we would have to use placeholders. Okay, so I'm just going to put an asterisk here. Use placeholders when necessary. And the purpose of that is so that we can line everything up. Every term needs a column, so we don't want to miss out the column where we might have a quotient having that missing term, or one of our products down here having that missing term. So this is how I do this. Okay, we're always going to divide the first term by the first term. Right? Everything else doesn't really matter. What happens down here is kind of collateral damage, if you will. So over here on the side, I'm going to go ahead and divide 6x squared by x. Right? So if I divide 6x squared by x, the x's will cancel and we'll get 6x. Right? So this is the first part of our quotient. So I'm going to put 6x. I'm not going to line it up with the 6x squared. I'm actually going to line all the x terms here in the middle. So I'm going to put 6x here lined up with its like terms. So after we divide, figure out how many times x can go into 6x squared. Now we're going to multiply. Right? Now we need to multiply 6x times both the x and the minus 4. So we're going to have to distribute that. So 6x times x is 6x squared. 6x times negative 4 is negative 24x. So there's our multiplying. Now after we multiply, remember we had to subtract, right? So I'm going to subtract this polynomial. Now I like to subtract mentally. Okay, so I'm going to put the minus out here and put parentheses because we got to make sure to subtract both of these terms, right? So I'm going to distribute the minus mentally. So 6x squared minus 6x squared, that's going to cancel. Negative 26x minus a negative 24x. This minus a negative means we're going to add 24. So negative 26 plus 24 is negative 2x. Right? So the last thing we're going to do is we're going to copy the rest of the polynomial down. So I'm going to bring the plus 12 down. And then we start the process over. Okay, we're going to divide first term by first term. So this time I want to divide negative 2x by x. So if I divide negative 2x by x, the x's will cancel and I'm just left with negative 2. All right, so the minus 2 is going to go above the constant here. And then I need to distribute just the minus 2 through the divisor. So negative 2 times x and negative 2 times negative 4 is what I'm going to write down here. So negative 2 times x is negative 2x. Negative 2 times negative 4 is positive 8. And then after we distribute, we need to subtract. Okay, subtract both. So put the parentheses there and go ahead and subtract mentally. Negative 2x minus a negative 2x. This minus a negative is adding. So negative 2x plus 2x, these cancel. 12 minus 8 is 4. Now 4 is the remainder this time. And how you can tell whether you're at the remainder is the remainder is always 1 degree less, or more than 1 degree less than the divisor. So since our divisor is linear, our remainder is going to be a constant. If our divisor was x squared, our remainder could be linear, right? So the remainder is always a lesser degree than the divisor. Remainder is lesser degree than divisor. So I'm going to go ahead and put the plus 4. I'm going to write it over x minus 4. Okay. So when we write this answer here is written in this first format, right? So if p of x divided by d of x, if I wanted to show that answer, I would do q of x plus r of x over d of x. So my quotient here is 6x minus 2 plus the remainder 4 over x minus 4. So I guess I'd like you to realize that this right here is q of x. Okay. Just this part is the r of x. Okay. This down here is our divisor, d of x, and so is this. This is also d of x. And then, of course, what's underneath the division symbol is our polynomial. Okay. So the other way of writing this is we could say P of x equals Q of x times D of x plus R of x. Let me go ahead and do that up here. P of x equals the quotient times the divisor plus the remainder. Okay, so the remainder is just 4. Putting it in the fraction form, that's doing the remainder over the divisor. So here is one way of writing the answer, and here is another. So let's go ahead and try this one more time. Hopefully I can get this done in 5 minutes here. All right. So this time we're dividing. Our polynomial is a 4th degree polynomial. Okay, and it has an x to the 4th. It's missing the x cubed, x squared, x constant. So we're going to have to put a placeholder there. The divisor is x squared, x constant, and so there's no missing terms there. So we're going to get our polynomial, 8x to the 4th, plus 0x cubed, plus 6x squared, minus 3x, plus 1, is being divided by 2x squared minus x plus 2. So we're going to divide this down until we get a remainder that is linear or less. All right, so first thing, we're going to divide first term by first term. So 8x to the 4th divided by 2x squared. If I go ahead and reduce this, 2 goes into 8 4, x squared goes into x to the 4th, x squared. Right? So we're going to get 4x squared. I'm going to line that 4x squared all the way up over here with the other x squared terms. So now I need to multiply. I'm going to distribute 4x squared to all 3 of these terms. Okay, so 4x squared times 2x squared is 8x to the 4th. 4x squared times negative x is negative 4x cubed. 4x squared times 2 is positive 8x squared. And now I'm ready to subtract. Okay, mentally, I'm not going to distribute that negative sign and show the work. I'm just going to mentally do this. 8x to the 4th minus 8x to the 4th cancels. 0 minus a negative is a positive 4x cubed. 6x squared minus 8x squared is negative 2x squared. And then that's all I have, so I need to bring the rest down. So I'm going to copy the minus 3x plus 1 all the way down. Now we got to start the process over again. Divide first term by first term. So 4x cubed divided by 2x squared. If I reduce this, I'm going to get 2x. That's the second part of my quotient, so plus 2x. Distributing 2x, I'm going to get 4x cubed minus 2x squared plus 4x, and that's it. Okay. So now I need to subtract these. All right. 4x cubed minus 4x cubed cancels. Negative 2x squared plus 2x squared cancels. Negative 3x minus 4x is negative 7x. And then I'm going to bring the plus 1 down. Now, negative 7x is 1 degree less than 2x squared. This is the remainder, because I can't do the division and get a whole number result here. So I'm going to put the remainder, negative 7x plus 1, and write it over the divisor, 2x squared minus x plus 2. Here's one solution. Right? The other way we can write that is the polynomial is equal to the quotient times the divisor plus the remainder. So we would get the quotient 4x squared plus 2x times the divisor 2x squared minus x plus 2 plus the remainder negative 7x plus 1. And if you were to multiply that out, you would get back to the original polynomial. All right, the rest of the synthetic division on the next video.